Well, good evening, everyone, and welcome here to the launch pad. You are looking at a live view of historic Launch Complex 39A at NASA Kennedy Space Center in Florida, where SpaceX, along with NASA, are preparing to launch the Noca-C IM-1 mission, the first launch from Launch Complex 39A heading to the moon since Apollo 17 launched in 1972. If it's your first time here, welcome. My name's Zach. I'm the founder and host here at the launch pad, and here at TLP, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together. We're glad to have you joining us here for the third, hopefully successful launch of the day. SpaceX was going for 3, and we also had that Russian Roscosmos mission to the ISS. SpaceX stood down from 1, but they're going for 2 today, and we're hoping to wrap up an incredible 8 hours of operations of multiple launches from around the world, 3 different launch complexes, and we are counting down to launch. SpaceX is targeting a liftoff time of 1:05 a.m. Eastern Time, and NASA is preparing to begin their live coverage along with SpaceX, and once they do, we will patch them in, of course, and listen in to NASA and SpaceX mission control as we go through the count. As this is a Falcon 9 mission, they have not begun propellant loading. That begins at the T-minus 39-minute mark with that go, no go for prop load. But we did have confirmation just over an hour ago that propellant loading on the lunar lander had begun and was underway, and that was ultimately what was one of the things that had us standing down from yesterday's launch opportunity. Now, as we wait for NASA and SpaceX to go live, we'll keep this live view on screen as much as we can here tonight. Take a moment, let us know in the chat where you're watching from. We'd love to give some shout-outs there, people tuning in all over the world, and it's great to have you with us for today's flight. If you haven't yet, take a moment, engage that like button, and share out the stream. Invite people to join us. As we said, this is a pretty historic launch, seeing 39A come back on, launching something out to the moon, which is really, really exciting as we really enter this new era of space exploration, of more missions not only to low Earth orbit, but to the moon and beyond. NASA and SpaceX are getting spooled up to begin their live coverage, and once they do so, we will patch them in. I'll bring that up on your screen so you can see them getting ready there. They're running through their intro, but as we wait for them to begin their live coverage, take a moment, let us know in the chat where you're watching from, and share out the stream and invite people to join us here. I'll be answering your questions throughout today's countdown and wait for deployment, so send those in the chat by tagging us at the launch pad, and I'll work on answering those live to the best of my ability as we continue through today's countdown. Let's listen in to SpaceX and NASA Mission Control.
Looking live at Launch Pad 39A, where in just a few minutes, SpaceX will begin fueling its Falcon 9 rocket right there. At the top is a lunar lander built by Intuitive Machines with NASA payloads on board. Hello, and welcome everyone to the Kennedy Space Center in Florida. I'm NASA's Megan Cruz. Liftoff of a Noca-C moon lander is scheduled for 1:05 a.m. Eastern Time after the team waved off a launch attempt yesterday. We'll talk more about that in just a few minutes, but for today, we are go for launch. And if everything goes according to plan, that lander will complete its journey 8 days from now with a landing at Malapert A, a 24-kilometer wide crater on the shadowy south side of the moon. Intuitive Machines, an American-based company in Houston, Texas, built and developed the lunar lander that will carry, among other things, 6 NASA payloads to the moon. We'll tell you all about those instruments and much more throughout this broadcast. But first, let's learn a little more about the moon-bound spacecraft. It's an autonomous Noca-C class lunar lander named Odysseus. Including the solar panels, it is 4.3 meters tall. Including the landing gear, it is 4.6 meters wide. The lander weighs approximately 675 kilograms and is capable of delivering about 130 kilograms of payload to the surface of the moon. Most of that spacecraft weight is fuel. Odysseus uses a liquid methane and liquid oxygen main engine that can throttle down to perform its final descent to the lunar surface in one continuous burn. Now, Intuitive Machines' IM-1 mission is funded by NASA's Commercial Lunar Payload Services Initiative, which allows acquisition of lunar delivery services from American companies for payloads that advance science, exploration, and the commercial development of the moon. Now, Odysseus's liquid methane had to be loaded shortly before launch, so SpaceX developed a new way to fuel the spacecraft while it was already attached to the rocket and on the pad. Joining me now live is Jesse Anderson at SpaceX headquarters in Hawthorne, California. And Jesse, the team decided to postpone yesterday's launch attempt just before that methane loading was set to begin.
Yes, that's correct, Megan, and thank you. As some of you may know, we stood down from yesterday's launch attempt due to off-nominal methane temperatures prior to stepping into methane load. Our teams have reviewed the data and started fueling preparations earlier today to allow the temperatures to better align to what we saw during our wet dress rehearsal earlier in the week. At 2 hours and about 20 minutes, methane fueling began and completed just before our live coverage started, and we are now ready to give launch another shot this evening. SpaceX is excited to partner with NASA as part of the Commercial Lunar Payload Services Initiative, and today we are thrilled to support the first U.S. lunar landing since the Apollo program ended more than 50 years ago. This mission marks our 14th of the year and second in the last 8 hours. Earlier this week, our team captured this photo of Falcon 9 and IM-1 with the moon just beyond. And this is such a great image with the vehicle's destination and its sights, and a wonderful celebration of the Lunar New Year. 2024 is the year of the dragon, which is considered one of the luckiest animals in the Chinese zodiac. This is very fitting as our own Dragon spacecraft has completed 40 missions transporting crew and cargo to and from the International Space Station, including Axiom 3, which concluded earlier this month, and Crew 7, which is currently docked to the station. And with NASA's Crew 8 mission just around the corner, we are on track to launch 50 people to orbit across all of our missions since 2020. As many of you may know, SpaceX was founded with the goal of making life multiplanetary, and with today's mission, we get one step closer to that becoming a reality. To support our growing manifest, we've recently made some new upgrades to Space Launch Complex 40, which you can see there with a brand new crew arm. With these updates, we're on our way to having 2 launch pads capable of supporting human spaceflight missions. If you're interested in helping advance the future of human spaceflight, check out spacex.com/humanspaceflight to learn more. In addition to flying people, SpaceX also enables researchers the opportunity to fly critical science to orbit on our Dragon spacecraft, which has carried over 1,000 research experiments to and from low Earth orbit and the International Space Station since 2012. Researchers can submit research proposals and explore current research opportunities at spacex.com/humanspaceflight/research. Enabling research in space paves the way for us to explore beyond Earth and make life multiplanetary. And today's mission furthers that goal by providing insights into the lunar surface environment and the ability to test technologies to better enable Artemis astronauts to land safely on the moon. For now, let's get familiar with the rocket that you see there on your screen.
Poll for propellant
Falcon
load
9
is complete. We are go for propellant loading and launch.
Some good call-outs there. Good for propellant loading. Falcon 9 is a 2-stage rocket and the first orbital class rocket capable of reflight. Since taking flight in 2010, our Falcon 9 rocket has made 297 flights and delivered all sorts of payloads to orbit. This is the 18th flight of the first stage booster supporting this mission. Falcon 9 is essentially 2 rockets in one. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin M1D engines. Named after the Millennium Falcon from Star Wars, the number 9 refers to the 9 Merlin engines that power Falcon 9's first stage, and you can see those on your screen. This is a photo of today's Falcon 9 getting ready to roll out to the pad earlier this week. These are the 9 engines that will be responsible for doing the heavy lifting today and getting to orbital velocity. Though there are 9 engines on the first stage, there are actually 10 engines on the vehicle as a whole. The second stage has a slightly modified engine on it. It's called the Merlin Vacuum, or what we call the MVAC engine. This engine has a larger nozzle, which allows the second stage to perform more efficiently in the vacuum of space. The first stage gets us out of Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. The large barrel structure with the pointed nose at the very top of the rocket is the payload fairing, and it's composed of two halves made up of carbon composite material that come together to protect the payload until we're in the vacuum of space. And speaking of the payload, the Noca-C lunar lander arrived at Kennedy Space Center in Florida back in December. Since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch. And as Megan mentioned earlier, during this mission, SpaceX proved out new procedures and hardware that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen starting about 2.5 hours before launch. This is a first for SpaceX. SpaceX teams modified Launch Complex 39A's pad and transporter erector, installing a new liquid oxygen tank, methane tank, propellant lines, and 2 control skids on either side of the top of the transporter erector. From there, the new propellant lines pass through a new Stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects leading to the IM-1 lander. Heat exchangers within the ground system densify the oxygen and methane as they flow from their storage tanks towards the lander.
Falcon 9 tanks are venting from the startup propellant load.
This allows the cryogenics to remain below their respective boiling points during the countdown and eliminate the need to top off the propellant while Falcon 9
The
is
LD
being
briefing
loaded for
the
launch.
abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the count. For urgent issues affecting the safety of the operation, operators shall call hold, hold, hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into launch abort. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
Just pausing for those comms there. Given the lack of methane used in the Falcon program, Falcon teams leaned on the expertise of Starship teams and are using methane sensors from Starship to verify the health and status of the lander and our fueling system. And so far, it continues to be a smooth countdown, and we're looking good for an on-time liftoff. In the meantime, let's check in with Josh Marshall over at Intuitive Machines. How's it going, Josh?
It's going well, Jesse, and thank you. And welcome into the broadcast booth at Intuitive Machines' Mission Operations Center in Houston, Texas. This room is just outside of what we call Nova Control. Nova being the nerve center of our entire lunar program. Right now, flight controllers are making their pre-flight checks and monitoring our lunar lander's fueling process on the pad. Take a live look into Nova Control. There are 12 console positions in a circular design. This unique shape wasn't a coincidence. We wanted to create a collaborative environment that folks can quickly communicate and make decisions. The design also pulled some inspiration from the Star Trek USS Enterprise bridge. Starting now, we have 3 primary flight controller teams working around the clock to monitor, command, and control our lunar lander during its journey to the moon's South Pole region. Here's a closer look at how we'll get there. The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic Noca-C class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2. Starting with separation for the launch vehicle on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7 days later, like an outfielder stretching out to grab it.
The first 4 days are dedicated to flight controllers in Houston firing the lander's 3D printed liquid methane and liquid oxygen engine to make small course adjustments to hit its orbit target around the moon. This particular coordinate system is called the B-plane.
And if you're just joining us, welcome here to the launch pad. On the left side of your screen is a nice zoomed-in view of the payload fairing on Falcon 9 as we count down 33 minutes, 35 seconds, and counting till launch. There's some beautiful atmospheric copyrighted music, so we're going to do a quick commentary check-in while we continue through the count. As always, if you guys have questions, you can send those in the chat by tagging us at the launch pad. We'll work on answering those live to the best of our ability. Today's Falcon 9 booster is booster 1060, going for its 18th flight. Today's mission is having a 188-day turnaround after previously supporting GPS 3. Starlink V1 launches 11, 14, 18, 22, and 24. It also supported Turkasat 5A, Transporter 2, Starlink 4-3 with Black Sky, 4-6, 4-9, 4-14, 4-19, Galaxy 3334, Transporter 6, Starlink 5-15, and most recently, Starlink 6-18 that was launched on September 23rd of 2023 from Slick 40, just a few miles down from the pad we're watching today. SpaceX and NASA are targeting liftoff at 1:05 a.m. Eastern Time, and the weather is looking absolutely beautiful down on the range as we continue through that count. We heard the call-outs there a little bit earlier for the go to begin propellant loading. That's a great sign. It's rare that we're live in advance of propellant loading, but with this being such an important mission for NASA's CLIPS program and ultimately the future of Artemis, we're excited that they have given us these live views in advance. We know we've got some of our TLP rocket chasers down on site. We've got Gavin and a number of the others scattered around the Space Coast, so make sure you stay tuned on our social media on X as well as our Discord to see some of their amazing captures here this evening. The next milestone we're expecting is not going to be till 16 minutes into the count. That's when the liquid oxygen will begin flowing onto the second stage of Falcon. Currently, RP1 is loading on both the first and second stage, and liquid oxygen is also now flowing onto the first stage of Falcon 9. T-minus 31 minutes, 35 seconds, and counting till launch. Everything continuing to look nominal for liftoff here today. As this is a historic mission, we are excited to hopefully get to see the payload deployment. That is expected 48 minutes, 24 seconds after launch. So we hope that you'll stay with us as we count down to that milestone, as well as watching that amazing booster landing, which will be landing at Landing Zone 1, right next door to Landing Zone 2, where we watched the Falcon 9 land earlier today. Let's listen back into NASA's commentators and SpaceX and NASA Mission Control.
Human missions to the lunar surface and beyond.
Or not, they're going to have one of their Artemis moon minutes, I think, here, with some more beautiful minutes, but music. But they're talking here that this is a historic mission from what they've been talking about leading up to today. This is the first launch from historic Launch Complex 39A at NASA Kennedy Space Center since 1972, when Apollo 17 last carried man to the surface of the moon. And it's a big milestone bringing back these lunar missions to NASA Kennedy Space Center. Obviously, we saw the launch of Artemis 1 just over a year ago, and now we're preparing for Artemis 2 late next year. And with that, we start flying people back towards lunar orbit and then the lunar surface a year later. But there's a lot to learn. We've only been to the moon a few times, and technology has changed a lot. So missions like this one, Noca-C, are critical to learn how to navigate the southern pole, to investigate the southern pole, and investigate the moon just in general more, so that when we do send man and women on SLS flying to the moon, we know that we are able to do so safely, and that they are able to have an incredibly detailed and thorough mission on their time on the surface. And we're going somewhere we've never really gone before. Now, as many of you know, we've been following many missions to the moon over the last few months. Some have landed successfully, some have had other journeys, but ultimately all of that goes into learning for this new Artemis era and the Artemis generation as we get to begin expanding to the moon and then prepare to expand onto Mars. And all of that leads in there today. If you guys have questions, you can keep sending those in the chat by tagging us at the launch pad. Let's listen back in to SpaceX and NASA Mission Control.
Mission task orders to deliver NASA science and technology to the moon. So over the following 4 years, Intuitive Machines has built an entire space program to support these CLIPS missions. The company completed its lunar lander in a new facility at the Houston Spaceport, just down the street from NASA's Johnson Space Center. Joining me on set now is Steve Artemis. He is the CEO of Intuitive Machines and former Deputy Director of Johnson Space Center. Good morning to you.
Good morning, Megan.
Let's take a look at this clock. You've been looking at it for quite a while now. So we are 28 minutes from launch. How are you feeling?
I'm ecstatic to be here. Such a historic moment. as we get ready to fire the Falcon 9 up and light the engines. All systems are go. The tanks on the lander are loaded, and we're just waiting for this last 28 minutes to light the candle.
So why did you start a company to commercially build and fly lunar landers?
Well, we started a company just because, you know, at the time NASA was thinking about a capabilities-driven framework and no real destination. And so I decided to retire early and think about a business where I could apply human spaceflight expertise in engineering and methodologies to in solving intractable problems around the world in oil and gas and energy, medicine, and aerospace. Well, in 2018, when the National Security Council came up with Strategic Directive 1, which was to say that the moon is now of strategic interest, we turned our whole company towards attempting to land on the moon, to return the United States to the moon for the first time in 52 years.
So we've been talking about your lander, obviously Noca-C, and your fellow co-founder, Dr. Tim Crane, mentioned that your core group had worked on Project Morpheus, and we have some video to show folks right now. You know, I remember that experimental prototype and the propulsion tests were completed right here at KSC. So how did Morpheus inform what you ended up doing with IM-1?
Well, Morpheus was a terrestrial test bed that was a liquid oxygen, liquid methane lander that actually we flew 37 times, and we learned about how to ignite and to fly a liquid oxygen, liquid methane engine. That core technology is the core technology of our Noca-C lander. In addition, the autonomous landing and hazard avoidance technology on board Morpheus, while it was older technology, those algorithms are the same kinds of algorithms we use for our hazard detection and avoidance, which is what we do on the moon to land on a place as rocky and craggy as the South Pole. And so we use that technology also, which is a derivative of what NASA produced, but we had in our know-how as we started the company.
And so you're talking about landing. You know, there have been a number of attempts to land on the moon recently, you know, by companies and other countries. Roughly half has succeeded, half have failed. So what has your company done to increase the chances of landing on the moon?
Well, I think first and foremost, what you have to do is you have to be humble about it, and you have to learn from and stand on the shoulders of all those who have gone before. So we looked really hard at every mission that has gone to the moon, and we looked for what mistakes or things in their design that caused their errors, and did those mistakes or did those design deficiencies, are they in our lander? And so we learned from others, and so we appreciate everyone who's tried to go before. But in addition, we bring things together quickly. We bring hardware and software together in the early stages of development testing and test often. And we put them on multiple test beds and test like we fly. And that's the key to success, and that's what I think we did. We learned from human spaceflight engineering to take the best of what we had and what we were doing and then streamline it to be agile and efficient. And we were working on a fixed price budget, so it was essential that we innovated. And I think over-constrained budget, over-constrained schedule, and an incredibly challenging thing like landing on the moon forced us to innovate.
Sure.
And that's the key.
Thank you so much. I appreciate it, and good luck tonight.
All right, thank you.
All right, so once the Noca-C lander gets to the moon, there are 6 instruments on board that will play a key role in navigating and studying the lunar surface. And the first one is this. It's a lightweight laser retroreflector array, or LRA. This passive optical instrument is a collection of 8, as you can see here, about half-inch reflectors or mirrors used for measuring distance. So the plan is, after Noca-C lands on the moon, future landers or spacecraft flying near Noca-C's lunar location can cast a laser towards the surface, and these retroreflectors will bounce the light back to the approaching craft. That reflected laser light will help determine how close the spacecraft are to the lunar surface, ensuring a smoother landing. So really, it's similar to when you're reversing your car and watching a camera to let you know just how close you are to an object. All right, so for more than, so let's go back now to Houston, where Josh Marshall is standing by live at Intuitive Machines with an update. And Josh, what is the latest?
Thanks, Megan. And if you're just joining us at home, welcome to Nova Control in Houston, Texas. Right now, flight controllers are monitoring launch pad activity and staying in communication with SpaceX's Launch Control in Florida, where we have another team working side by side with SpaceX to monitor Noca-C's fueling and launch readiness. After launch, flight controllers working each of Nova Control's 12 positions will prepare for first contact with our Noca-C class lunar lander. That process won't start until a spring force gently pushes the lander away from the launch vehicle's second stage, which is scheduled for about 48 minutes after liftoff. After separation, our lander's orbit is called trans-lunar orbit. This enables Noca-C to reach lunar orbit in about a week, but requires a lunar lander with a very capable engine. Noca-C was tailor-made for NASA's CLIPS initiative and supporting commercial lunar exploration. It's a pillar of Intuitive Machines' lunar access services, and we took a deep dive into what makes Noca-C qualified for this historic undertaking. Landing site is called Malapert A. It's named after 17th century Belgian astronomer Charles Malapert and is expectedly made of lunar highland material, similar to the material studied during Apollo 16, which was also launched from Launch Complex 39A, where we have more from Megan. Megan.
All right, thanks, Josh. And actually not far from the Malapert A landing site is the Malapert Massif region, and that is one of the 13 candidate regions being considered for the Artemis 3 landing. Okay, so a second NASA instrument on board the Noca-C lander is NASA's Radio Frequency Mass Gauge, or RFMG. The instrument is essentially a fuel gauge to estimate the amount of propellant in spacecraft tanks in specifically a low-gravity space environment. So during this mission, RFMG will estimate the amount of propellants in Noca-C's tanks. Once proven, RFMG technology would demonstrate significantly more accurate measurements of a fuel tank's fill level without requiring a thrust to provide a force upon the fuel in order to measure it, as current technology does. For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. To get there, SpaceX and NASA teamed up to develop the human landing system. Here's a closer look at your Artemis Moon Minute. Human landing system. Let's go back to Jesse Anderson live at SpaceX headquarters in Hawthorne, California. Jesse.
Great. Thank you, Megan. Down at Starbase, Texas, we're continuing to build, test, and fly Starship, the world's most powerful launch vehicle ever developed. A fully reusable Starship is capable of carrying up to 150 metric tons to orbit and up to 100 passengers. We completed 2 test flights last year, and 2024 is lining up to see even more Starships take flight. We're still in the testing phase, but major milestones like flying at a high cadence, full system reuse, and on-orbit refilling are key priorities. Refilling on orbit will enable the transport of up to 100 tons all the way to Mars. Down at Starbase, we're gearing up for Flight 3 of Starship. We have a fully stacked vehicle on the pad for the first time since Flight 2 in November of last year, ready to go through pre-launch testing to get ready to fly. We're also building a second Starbase launch tower to further increase Starship's flight opportunities. Also in testing, our engineers are proving out all systems necessary to make a trip to the moon possible, such as propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatch opening down to the lunar surface. In partnership with NASA, SpaceX's Starship Human Landing System, or HLS, will put the first Artemis astronauts on the moon. We are part of the global team, which includes Intuitive Machines, that will further exploration of the moon under the Artemis program. SpaceX will perform 1 uncrewed demonstration flight before the Artemis 3 mission, which will be the first human surface expedition since 1972. To that end, SpaceX has been hard at work getting Starship ready for its moon missions and ultimately Mars. There's so much to look forward to, and it's just incredible that humans are finally going back to the moon, and the efforts of SpaceX and Intuitive Machines get to play a vital role in that. For those of you who have just joined, we're just about 15 minutes from launch of the IM-1 mission. Let's check back in with Josh at Intuitive Machines. Josh?
Thanks, Jesse. We're counting down the minutes to launch and looking forward to Intuitive Machines firing its Nova-C class lunar lander's engine about a day after liftoff. Nova-C uses an environmentally friendly mixture of liquid methane and liquid oxygen. It's a propulsion system with deep roots to NASA's Project Morpheus. Morpheus was a prototype lander engineers at NASA's Johnson Space Center used to integrate technologies for future spacecraft that could land on a variety of destinations in our solar system. The project integrated NASA's autonomous landing and hazard avoidance technology designed to enable a spacecraft to identify, descend, and find a safe landing site that is relatively flat and free of large boulders, rocks, and craters. In the video on your screen, you can see that signature blue fire synonymous with liquid methane and liquid oxygen engines. That's the same fuel used on Nova-C. From December 2013 to December 2014, Morpheus completed 13 free flight tests at the north end of Kennedy's shuttle and landing facility. And joining me now is our co-founder and Chief Technology Officer, Dr. Tim Crane. Tim, before starting Intuitive Machines with your fellow co-founders, Steve Artemis and Dr. Cam Gafarian, you were working on other things at Johnson Space Center to include Project Morpheus. What can you tell me about Project Morpheus and how that foundings of technology led to us getting to the launch pad today with your company?
Well, one thing I can tell you is I get chills watching that footage because it takes me right back. But this is a journey that clearly our prop technology was a big part of Morpheus we brought forward. Also the all-hat, the autonomous landing, hazard avoidance task, a lot of our navigation, the way we do software, the way we test our systems, and even the discipline about knowing when some technology needs to wait for a future date so we can get to flight. All of that came from the Morpheus experience.
And, you know, just about a year ago, you got to see those Project Morpheus tanks again, but this time they were in your facility and you were testing them with your company. What can you tell me about speeding up innovation through NASA's Reimbursable Space Act agreement?
Well, NASA really is a national treasure in terms of knowledge and capability, and in some places, equipment. And we had a supply chain issue with some of our tanks, and we needed to get our test rig up and running. And we knew the Morpheus tanks were in surplus, and reached out to NASA, and they facilitated getting those tanks to us so that we could proceed with testing while our flight tanks were coming in.
And real quick, while you have you, why liquid methane, why liquid oxygen?
Well, in the near term, it's very easy to work with. It's environmentally friendly. It's non-toxic. It's very robust to changing conditions. Down the road, it's the exploration fuel of the solar system, and we can make it on Mars for bringing spacecraft back from there, so we don't have to take all the fuel with us.
Well, Tim, I know you're burning back to get back into mission control, watching your team that you fostered throughout all these years, and listening to that IM-1 mission loop. We do appreciate your time today, and thanks for stopping in.
Thanks, Josh.
NASA instrument on the Noca-C lander for this IM-1 mission is the Lunar Node 1 navigation demonstrator, also called LN1. That's much simpler. It's similar to when you use GPS to get to a destination. Let's take a look at how it works and what it will do to help support future surface and orbital operations.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon. I'm holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat, and then to talk to the antenna, which mounts here.
And if you're just joining us, welcome here to the launch pad. On the left side of your screen is a punched-in view of the top of Falcon 9, where the Noca-C lunar lander is fueled up, ready to go. T-minus 10 minutes, 35 seconds, and counting till launch of this historic mission from Launch Complex 39A, the first flight from Launch Complex 39A to the moon since 1972 with the Apollo 17 crew. As we continue through the count, if you guys have questions, you can keep sending those in the chat by tagging us at the launch pad, and we'll work on answering those live. Make sure you also take a moment and share out the stream and invite people to join us for this historic mission. We'd love to have them join us. As we continue through the count, T-minus 10 minutes, 3 seconds and counting. Let's listen back in to the NASA commentators and mission control as we go through the final minutes of the count.
Good morning, Megan. So talk to me about some of the key takeaways as NASA moves forward with commercial lunar vendors.
Yeah, so the Commercial Lunar Payload Services Program is super important to NASA. It really is transforming our method of doing business. It's leveraging industry's emerging capabilities of actually providing end-to-end service for us. So rather than us having to build our own, we can now procure it. And it's not only, we're not the only customer. Other government organizations, industry, academia from around the world are all going to procure these services. And there is risk associated with it, though. So we recognize that as we're evolving this capability.
Yeah, so I was just going to ask you that. I mean, because we know that there are risks,
Spacecraft is go for launch.
spacecraft is go for launch. We just heard a call for that. What involvement does NASA have when our commercial providers are assessing the risks?
So what's really important about this too is recognizing that industry is in the lead in providing these services, so they're the decision makers. So ultimately, what will happen is, you know, as they're making their decisions, we obviously bring great experience along with us, and we will stand shoulder to shoulder with them and support them through the legal process, through contracts and all, but we will bring to bear what we need to support them to make sure that this is successful.
Sure. So it seems like, again, yes, we're fully committed to the CLIPS initiative. So what is NASA sending to the moon on future CLIPS flights?
So again, super exciting time for NASA. You may or may not realize we have 40 manifested payloads on the CLIPS mission. So over the next few years, and that's just for the NASA payloads, right? So you've got industry and academia as well. But focusing on Intuitive Machines, which is our purpose for being here tonight. We're super excited about their efforts here. So they actually have another payload that's going to be launching later this year. They're going to be delivering the Prime 1 drill and spectrometer, which is actually going to support our in situ resource utilization and support a future human presence on the moon.
Sandra, thank you so much. We're excited to see what CLIPS can do for NASA and for humanity, really, with what we plan to do with the Artemis program.
Thank you.
Thank you so much.
Go Falcon 9.
That's right.
And go IM-1.
Perfect. All right, so let's send it back to our friends at SpaceX in Hawthorne, California, as they walk us through the final moments of the countdown, and then I will see you guys after launch.
Awesome. Thank you so much, Megan. At T-minus just under 7.5 minutes, all systems are currently a go for an on-time liftoff. Next up, in just about a couple minutes, the structure next to the vehicle, known as the strong back, will begin to retract away from the vehicle. But while we wait for that, let's talk about what it takes to actually get to orbit. In order to get the rocket and payload into any orbit, the rocket not only has to go up really fast, but it also has to go sideways.
Engine chill has started.
As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, an image of firing a cannon from a really high mountain is what you can see there on your screen. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground.
Stage 1 RP1 load is complete.
This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example, and it provides enough power and horizontal velocity to the second stage carrying the spacecraft, enabling the spacecraft to be placed into orbit around the Earth. Now, you'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T+10 seconds, at which point we will begin that shift in orientation, gimbaling the engines so that Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. Now again, at T-minus 5 minutes and 38 seconds, all systems are currently go for liftoff. The strong back is going to begin retracting away shortly. In preparation for that retraction, the clamp arms, which are located just around the second stage, just below the fairing, will begin to open. Once those are fully open, then the TE, or the strong back, can begin to recline away from Falcon 9. And you can see that on your screen, those clamp arms just below the fairing there. Now, the vehicle is nearly fully loaded with propellants, and we did hear a call out that stage 1 prop loading has concluded. We are still loading blocks. And there's that call out that we are beginning that process for that strong back retraction. Propellant loading is continuing on the vehicle and will complete at T-minus 2 minutes. The range is currently green and ready to support liftoff. And if for some reason we do not launch today, we do have a backup opportunity on Friday, February 16th at 1:12 a.m. Eastern Time.
Strong back retract in progress.
And good call-outs there. The strong back retraction is now in progress, and it will be slow and slight, but we should see those clamp arms begin to open up there. And there you can see it on your screen. Those clamp arms are now opening up. Again, once they are fully open, that will allow the transporter erector, that structure next to the vehicle, to begin to retract away. You should see that TE begin to move away, very slow and slight. But at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. And there you can see on your screen that TE is now moving away from Falcon 9. Falcon 9 uses two propellants, a refined form of kerosene called RP1, or rocket propellant 1, as a fuel, and LOX, or liquid oxygen, as an oxidizer. Now, fire generally needs three elements to ignite. That's heat, fuel, and an oxidizing agent, which is usually oxygen. This is what's known as the fire triangle. In our case, the liquid oxygen is chilled below its boiling point so that it has a much greater amount of mass per volume, allowing us to load more of it into the vehicle. And in addition to these two propellants, we also use the chemical TTAB, or triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go, but it's the TTAB that sets the match to the propellant mix. And we did hear a call out that stage 1 liquid oxygen loading is complete. Coming up next, in the next couple of minutes, at T-minus 60 seconds, Falcon 9 will go into startup. That means that the rocket's autonomous flight computers will have taken over the launch countdown. And at just inside T-minus 2 seconds, we will light those Merlin 1D engines for liftoff. The Intuitive Machines payload continues to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. We are currently green for weather, and the range is ready to support a T0 of 1:05 a.m. Eastern Time. And just waiting for the call out for liquid oxygen. Right on time. Stage 2 liquid oxygen loading is now complete. That concludes propellant loading on the vehicle. That means that Falcon 9 is fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Weather is 90% chance of
ground gas closeout.
Good weather for T0. And we are just about 30 seconds away from Falcon 9 going into startup. Now that propellant loading is complete, we are beginning to vent out the lines, the propellant lines on that transporter erector there, so you can see more of those white clouds around the vehicle. Startup is coming up here in a couple seconds.
Falcon 9 is in startup.
Great call out. That means that the internal flight computers have now taken over the launch countdown. We are now just waiting the final go from the launch director.
LD, go for launch.
An excellent call. All systems are go for launch of Falcon 9 with the Intuitive Machines lunar payload.
30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff. Go SpaceX, go IM-1 and the Odysseus lunar lander. Vehicle pitching downrange. Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical
Nominal
term being
power
gimbaling, and that turns the rocket horizontally. And
Mach 1. Max Q. Back shell has started.
Yep. We have a few events coming up in quick succession here. That will be MECO, stage separation, SES-1, and then the boost back burn startup on the first stage vehicle. MECO, or main engine cutoff, is where we shut down all 9 of those M1D engines on the first stage vehicle. That helps slow the vehicle down in preparation for stage separation, which is where the first and second stage will separate. And the first stage booster will begin its trip back to Earth. And the second stage vehicle will ignite that MVAC engine with SES-1, or second stage engine startup 1. And then the boost back burn will begin on the first stage vehicle, which is one of 3 burns that's required for the vehicle to make its way back to today's landing zone. And this burn assists with the vehicle to reorient itself back towards land.
Stage separation confirmed. And back ignition. Stage 1 boost back startup.
And there we saw and heard those call-outs for MECO, stage separation, SES-1, and the boost back burn startup on the first stage. Some great views there. Now, the first stage is currently performing its boost back burn. This is where we ignite a few of the engines to bring the trajectory towards the landing site. And coming up here shortly will be fairing separation.
Fairing separation confirmed.
And an excellent view of fairing separation and an amazing view of the IM-1 payload attached to Falcon 9's second stage. Fairing deployment has been confirmed, and we will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Bob.
Both vehicles are on nominal trajectories.
And some good call-outs there. And in about 3 minutes, there will be a couple more burns on our first stage to prepare for landing at landing zone 1 at Cape Canaveral. Again, we've completed the boost back burn on the first stage. That's the first burn of 3. The next burns coming up will be the entry burn and then the landing burn for the first stage vehicle. Now we are at T plus 4 minutes and 17 seconds into today's mission. IM-1 is SpaceX's 14th launch this year, and the lunar lander on board could be the first U.S. moon landing since the Apollo program ended more than 50 years ago. You can see on your screen that the MVAC engine on the second stage is ignited, and we are currently in the first of 2 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn coming up on that first stage vehicle. Again, that is the second of 3 burns. For the entry burn, we will relight 3 of those M1D engines, starting with the center E9 engine, followed shortly afterwards with the E1 and E5 engines. This helps slow the vehicle down as it enters back into the Earth's atmosphere. Now we need to slow down the vehicle to reduce re-entry forces, and that helps us to recover and reuse the first stage. Again, what you're seeing on your screen is a view of the MVAC engine on the second stage. And you can follow the speed and altitude of both vehicles on the bottom left hand of your screen. That is showing the stage 1 telemetry and stage 2 telemetry on your right-hand screen. And we are coming up on the entry burn for the first stage vehicle in just about 20 seconds or so. And what you're seeing on your screen on the left-hand side, it's a little dark there, but that is a view from the first stage. And with the entry burn, we should see that screen light up with the engines reignited.
Stage 1, entry burn, startup.
And there you can see that the entry burn has begun with those engines relit.
Stage 1, entry burn, shutdown.
Stage 1, FTS.
And a very quick
Both
entry
vehicles are on
burn
nominal
there.
trajectories.
Great call outs, both vehicles on nominal trajectories. And as I mentioned, that was the second of 3 burns required for this booster to return back down to land. The next and final burn will be the landing burn. That's just a center E9 engine burn, and that helps slow the vehicle down just in time for landing. That's coming up in just about 15 seconds or so.
Stage 1, transonic. Stage 1, landing burn.
And there you
Stage
can
2
see on
from
your
terminal
left-hand
guidance.
screen the landing
Stage
burn
2
has
FTS
begun. Let's
06.
watch as Falcon 9. Let's
Stage
watch
1,
as Falcon 9 touches down for landing.
Stage
And a
1,
great
landing burn.
view there. That is we just had confirmation
Nominal
of booster
orbit
landing.
insertion.
We also heard and just heard SECO 1 as well as a confirmation of good orbit for our Falcon 9 second stage carrying our IM-1 payload. Now with that landing, that marks SpaceX's 273rd recovery of an orbital class rocket, including first stage landings for Falcon 9 and Falcon Heavy. And with confirmation of good orbit, the mission isn't over yet. Coming up, we do have the second burn of our MVAC engine, or SES-2, on board the second stage around the T plus 41 minute mark, followed by spacecraft separation. So until then, we're going to send it over to Megan at KSC. Megan?
Thank you, Jesse. And if you're just joining us, welcome to the Space Coast of Florida, where we just witnessed live the liftoff of the moon-bound spacecraft and Noca-C lander called Odysseus. And you know, we see a lot of launches here from Kennedy Space Center, but it really, truly never gets old. So Odysseus launched on top of a SpaceX Falcon 9 rocket from Launch Pad 39A here at Kennedy Space Center. Intuitive Machines, an American company based in Houston, Texas, developed and built the lunar lander that is carrying, among other things, 6 NASA payloads. And if everything goes as planned, in 8 days, that Noca-C lander is expected to land on the shadowy south side of the moon. Make sure you stay with us. Our broadcast here on NASA TV will continue through Odysseus's acquisition of signal, which is expected to happen around 1:55 a.m. Eastern Time. Now, before launch, we highlighted 3 of 6 NASA payloads on board the Noca-C lander. The 4th is the SCALPS payload, which stands for Stereo Cameras for Lunar Plume Surface Studies. It includes 4 cameras at the base of the lunar lander. The images it captures will help scientists understand how landings impact the lunar surface for this mission and future ones.
SCALPS is an array of small
And if you're just joining us, welcome here to the launch pad. T plus 10 minutes, 24 seconds, and counting into flight. We are now 37 minutes, 10 seconds away from payload deployment of the Noca-C IM-1 lunar lander, the first American lunar lander going out to the moon from Launch Complex 39A since Apollo 17. We hope that you'll stay with us here while we wait for that deployment. If you guys have questions, now's the time to send those in the chat by tagging us at the launch pad, and we'll work on answering those live to the best of our ability. I know we saw a question coming in from John Ferris. When does Lunix 1 launch? We're hoping to give out some updates as we get those from the launch provider with that date moving around in the launch vehicle as well. So stay tuned for updates from that once we are told that we are allowed to do that, but they are underway now. We're going to listen back into NASA commentary as we continue to wait for deployment. 36 minutes, 25 seconds from now. We keep sending in those questions, and I'll be back with more commentary and questions in just a few minutes. Stay with us.
Passing minute, we are closer to receiving the lander's data in Nova Control. Right now, flight controllers are standing by for launch vehicle separation, followed by acquisition of signal. That's when the lander makes first communications contact, sending critical health and flight data into Nova Control. And we want to bring you closer to our Mission Operations Center to experience a few types of information that flight controllers are looking at during the mission. This particular screen is called the Deorbit Descent and Landing, or DDL screen. This screen is primarily used by the mission director and landing system experts. It's used primarily while Noca-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side. The line is the tail where Noca-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Noca-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration over time, with the ability to look back at what has happened. For some reason, flight controllers have lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Noca-C's navigation system is in good health. That's because every measurement Noca-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Noca-C to the lunar surface. It's no small feat, and the tireless effort of our entire Intuitive Machines team has brought us to this moment, standing by for launch vehicle separation and acquisition of signal in approximately 40 minutes. Until then, we'll toss back to Megan with more on the challenges that lie ahead of the IM-1 mission.
Yeah, we've been honest about it. You know how difficult it is to get to the moon. We haven't done it in more than 50 years, but the CLIPS initiative is going to change that. NASA and American companies who have teamed up to explore the moon know a lot of research needs to happen before astronauts head back to the lunar surface. In the end, the rewards outweigh the risks.
Landing on the moon is
to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
it's
cost savings for NASA. To talk more about that, we have Joel Kearns here now. He's the Deputy Associate Administrator for Exploration in NASA's Science Mission Directorate. It's a very good morning, Joel. We just saw launch.
Oh, beautiful launch. Fantastic. It's great to be back here, Megan.
Yeah, perfect. So, how does NASA maintain oversight when it comes to this, the CLPS vendors? Obviously, this is a new initiative for us.
Yeah. Well, remember, what we're doing here is NASA is not doing these missions. We're actually buying passage on commercial companies' missions for our experiments and our cargo. So we have established this group of pre-certified 14 U.S. companies that we can go to and have them bid to do a specific mission for us, to land at a certain place of the moon, and to bring our cargo or our experiments with it. Once we actually select a company to do that, we assign them a NASA engineer who's their liaison. They represent all the NASA cargo and payloads to the company, and they represent the company back to NASA. As part of that, we get a lot of insight into how the company is actually going to do their mission. We try to make sure they really understand what they need to do to make our cargo successful, our data come back from the moon. And then we continuously learn from that, and we feed back and make sure that all 14 of those companies are certified to be able to do this work.
So a very collaborative effort. And we're talking a lot about a commercial lunar economy. That's kind of the end goal. So how does that shape up with CLPS? How do we get there?
A couple of different aspects. When you hear us talk about wanting to form a lunar or a cislunar economy, in the short term, what that really means is encouraging the companies to get other non-NASA organizations to pay them to bring their experiments or their cargo on the moon. But it's actually a lot broader than that. Just by offering these contracts to industry and having them build their own missions that we can take a part of, the companies are developing their own, you would think of as a parts and high-tech ecosphere on Earth that's part of the lunar economy. Over the years, they've had to figure out ways to build these robotic landers. In some cases, helping other companies do new advanced high-tech components like rocket engines or fuel tanks or sensors, which didn't even exist 5 or 6 years ago. Of course, we can say now we're talking about small payloads going to the moon from commercials or having suppliers on Earth, but what the goal is in the long term is for these CLPS companies to be able to take to the moon work or goods or services of other bigger companies that just want to do work in space.
So what would you say is the agency's confidence in CLPS? You laid out a very ambitious vision.
Yeah. Well, we think that the benefits of having this be successful, where we go out to companies, and in effect we pay for a service to get our things to the moon, it's just so positive that we really are committed to exercising this model and seeing how American business does. Now, NASA is a learning organization, so at every attempt that the companies make, we're always looking at. We're trying to learn from that and figure out how we're going to adjust things to go forward to do next. But we're really committed to this public-private partnership and service model that we've embarked on.
Joel, thank you so much. I appreciate you being here.
Thank you.
Okay, so the fifth NASA technology we want to dive deeper into is called ROLSYS, which stands for Radio Wave Observations at the Lunar Surface of the Photoelectron Sheath. There's going to be a quiz on that later, so I hope you all took that down. ROLSYS will use 4 antennas and a low-frequency radio receiver system to determine how nearby radio emissions from the Sun, Earth, and other planets could interact or interfere with science conducted on the moon. This experiment is something that has never been done before. It will perform many tests, including detecting solar radio bursts, radio emissions from Jupiter, and dust impacting the surface of the moon. ROLSYS could even serve as a baseline for a future radio observatory on the lunar surface. Let's get another update from Josh Marshall, who's standing by live at Intuitive Machines headquarters in Houston. Josh.
Hey Megan, when I asked our mission directors about what should I expect from launch vehicle separation on until about AOS, and they said, well, we're just going to be patiently waiting. And after 4 years of hard work to get to this point, this must feel like an eternity. Let's take a live look into Nova Control. For some of the folks working today's launch and acquisition of signal shift, they've been working on the IM-1 mission since before we were awarded the task order back in 2019. Even folks that started in the past couple years or the past few months have poured their hearts and minds into this IM-1 mission. In fact, every Thursday, Intuitive Machines holds a lunch and learn for folks to learn more about the company. And just a few days ago, one of our flight controllers, Brooklyn Herman, was describing today's events and said the opportunity to land on the moon has been a dream for her whole life. And everyone at Intuitive Machines is part of this beautiful mission, an incredible opportunity. And while we do have a moment just in between launch vehicle separation, we want folks at home to know that that same sentiment echoes through everyone at Intuitive Machines. We are humbled by the gravity of our mission, yet emboldened by the boundless possibilities that lie ahead, starting with acquisition of signal, which we expect to happen just a few minutes after launch vehicle separation. For now, our team will continue to patiently wait and toss it back to Florida to introduce another IM-1 mission payload. Megan?
Well said, Josh. Okay, so the sixth and final payload has 3 telescopes that will help the spacecraft land safely. In the past, astronauts had to use a viewfinder or rely on radar.
So the program is taking NASA back to the moon, and everything
So, if they make it to the moon in 8 days, what happens next for each of them?
So even the payload's work starts even before they get to the moon. Intuitive Machines, while it's transiting towards the moon, will turn on the NASA payloads to make sure that they survived launch and are operating as we expect. And then you've heard about the RFMG, the radio frequency mass gauge. It will be operating the entire time all the way to the moon and down to the surface to make sure that it's monitoring propellants and collecting the data that it needs to achieve its missions. And then during descent, you heard about NDL, the Navigation Doppler LiDAR, and SCALPs. They're going to be operating during descent and collecting their data. And then once on the moon, Intuitive Machines will turn on our other NASA payloads, and they'll take turns collecting data until they achieve their missions.
How are these instruments selected?
Early on in the CLIPS initiative, NASA turned to our scientists at the NASA centers to identify science, payloads, and technologies that were relatively mature in their designs. We did that because we wanted the payloads to be ready for when the landers were ready to integrate them onto the landers and deliver them to the moon. So then NASA turned to the vendors and said, okay, you pick from this pre-selected list of NASA payloads which ones you think you can successfully integrate onto your landers and deliver to the moon. So Intuitive Machines actually chose the payloads that are on its delivery.
Deb, thank you so much. I can't wait to see what we discover with these payloads.
Me too. Thank you so much.
Thank you. Okay, so now we're going to step aside while we await our next big milestone, the second burn of the second stage of the Falcon 9 rocket, and then right after that, the separation of Intuitive Machines' lunar lander from that second stage. We are expecting that to happen about 20 minutes from now, so we will see you then.
You can see that MVAC engine has now relit. Again, this is just about a 53-second burn, so just under a minute. And shutdown of this MVAC engine coming up here in just about 10 seconds or so. And there you can see
nominal
on your
orbit
screen that
insertion.
the MVAC engine. The MVAC engine has shut down, and we did hear that call out for a confirmation of good orbit. So with confirmation of a good orbit, it looks like we are on track for spacecraft separation in just a few minutes from now, just about a little over 5 minutes. Now, it's been a great launch so far. SpaceX did begin fueling of the IM-1 lander on the pad about 2 hours and 20 minutes before liftoff. And we did talk about that a little bit earlier in the webcast. It's a totally new procedure and new hardware for SpaceX that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen. Now, to be able to do that, SpaceX teams modified Launch Complex 39A's pad and transport erector, installing a new liquid oxygen tank, a methane tank, propellant lines, and 2 control skids on the transporter erector. Then from there, the new propellant lines pass through a new stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects that lead to the IM-1 lander. And given the lack of methane used on the Falcon program, Falcon teams actually leaned on the expertise of Starship teams and used methane sensors from Starship to verify the health and status of the lander for our fueling system. Now, if you're just now joining us, we are just about 4 minutes away. We're awaiting spacecraft separation of the IM-1 lunar lander, which is still currently attached to Falcon 9's second stage. And we did just a couple of minutes ago had a good last and final burn of our MVAC engine. That was SES-2 and SECO-2. And now the vehicle is continuing to coast with the spacecraft attached until it reaches the correct targeted drop-off orbit. And just to recap, if you're just now joining us, we did have an on-time liftoff at 1:05 a.m. Eastern Time, and everything has been proceeding nominally. Stage separation occurred just about 2.5 minutes into flight, and that was followed by the successful landing of our Falcon 9's first stage back at Landing Zone 1, or LZ1, and that was the 18th landing for this specific booster. Now, for those of you following along, this booster has supported GPS-3, Mission 3, Turksat 5A, Transporter 2, Intelsat G33 and G34, Transporter 6, and 12 Starlink missions. So pretty impressive and veteran booster for today's mission. At about T plus 7 minutes and 46 seconds, we did have a successful second engine cutoff, or SECO-1. That was the first burn of the 2 burns for this mission, and that was followed by confirmation of good orbital insertion. The vehicle was then able to coast for a bit there, and then again, just a few minutes ago, we did have the second burn for this MVAC engine. 2 burns required to reach the targeted drop-off orbit for this IM-1 lander. And now the vehicle is coasting with payload attached, and we are just a couple of minutes away from spacecraft separation. IM-1 could become the first U.S. lunar lander since Apollo's last landing in 1972, almost 50 years ago, and could be the first commercial lander to succeed in reaching the moon's surface. Again, we are just about a minute and a half, just under a minute and a half away from spacecraft separation. And on your screen, as we wait to get some live views, you can see on your bottom right-hand screen the speed and the altitude of the Stage 2 vehicle, again, still carrying the IM-1 spacecraft. And there's that live view there. Again, this is a view from the second stage vehicle looking aft at our MVAC engine there. We are patiently waiting spacecraft separation here, just under a minute from now. And now that we have this live, perfect timing, we've got this great live view of the IM-1 lander right before it begins its 8-day journey to the moon. This is such an incredible view and very exciting that we have spacecraft separation coming up here in just a few seconds.
IM-1, Odysseus lunar lander, separation confirmed.
What an incredible sight to see the IM-1 Noca-C lunar lander drifting away from Falcon 9's second stage, confirming spacecraft separation. From all of us here at SpaceX, we are wishing the IM-1 lander a great flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services initiative to deliver science and technology to the lunar surface, and we thank NASA and Intuitive Machines for entrusting us with today's historic mission to the moon. For those of you following along, you'll know that this mission marks our 14th of the year and second just today. Congrats to the SpaceX team. We're just in February, and we've already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE. And we're gearing up for the Crew 8 mission before the end of the month. Check out spacex.com/launches for up-to-date missions and schedules. And before we sign off, let's go back to Josh at Intuitive Machines. Josh?
What an incredible, incredible view. Just a few moments ago, our flight controllers inside of Nova Control heard that confirmation of launch vehicle separation. This starts the countdown toward our lunar lander's autonomous commissioning. During this milestone, the lander is going through the steps required to power on, determine its position relative to the sun, and make communications contact with flight controllers in Nova Control. It's an autonomous process that takes several minutes. In that time, we'll walk you through what's happening in space approximately 223 kilometers or 139 miles from Earth. At launch vehicle separation, a spring force gently pushes Noca-C away from the launch vehicle's second stage. We just saw that, allowing the lander to deploy and drift away toward the moon. Brake wires connected to the launch vehicle let the lander know it has deployed, and Noca-C starts an internal timer to count down to when it's safe to turn on. After the timer finishes, Noca-C's primary systems are expected to autonomously power on. This includes guidance, navigation, and control, or GNC for short, automated flight management software, radios, sensors, and thermal control. The GNC system powers on the cold gas helium reaction control system to stabilize the vehicle's attitude, because at this point, the lander does not know where it's pointed, but it can stop any residual spin motion. This is much like a person spinning in a chair with closed eyes can stop spinning without knowing which way they're pointing when they stop. After controlling the spin rate, special cameras known as star trackers autonomously match images of the distant star field and provide Noca-C with its orientation. Software then takes those star tracker measurements and processes them through an algorithm known as the Kalman filter to correct the onboard orientation. The lander now has two critical data points: its attitude relative to the star field and a reference position from the estimated launch vector. With these data points, Noca-C may command its reaction control system to maneuver the lander's top deck solar array toward the sun for illumination, generating maximum power. All of these steps are expected to be happening right now, and when autonomous commissioning is complete, our Noca-C lander named Odysseus turns on its communication radios and makes first communications contact known as acquisition of signal, or AOS. Making that communications connection involves more than the lander's operations in space. It takes careful coordination here on Earth too, using Intuitive Machines' Lunar Data Network. The network was designed to support NASA's CLIPS initiative, government services, and other commercial efforts using line-of-sight and data relay services for spacecraft in cislunar space, which also includes low Earth orbit. The secure network is made up of Nova Control, which we're keeping our eyes on right now, and strategically placed ground stations spread across the globe. The ground stations are expected to provide near continuous communications with Noca-C during the entire IM-1 mission. With that entire network available, our flight controllers responsible for communications and ground stations will be the first people in Nova Control to start seeing data from our lunar lander, which means the ground station assigned to this part of the mission has locked onto Odysseus's signal. Now, from the lander to Nova Control, all of these innovations and capabilities are being put to the test right now as we prepare to enter our nominal acquisition of signal window with Noca-C. Right now, we are listening into the mission audio loop and looking live into Nova Control.
SpaceX just deliver us the OPM file.
Okay, copy. You're good to process in the background while we work contact.
Okay, I'll work with Fido on this.
Right now, we estimate that the lunar lander is traveling about 10 kilometers per second, which is about 24,600
All right, I want to make sure
miles
Com's
per
happy
hour.
with it. Com?
Standing by. I don't see packets updating in packet counts unless I'm looking in the wrong spot. And I'm not seeing anything populate in AOS.
So we're still standing by for autonomous commissioning and making that first ground communications from the lunar lander in space. We expect the carrier lock call to come from the comm or ground network stations inside of Nova Control. And this is Houston's first commanded lunar mission since Apollo 17.
All right, I see packets. And I see...
All right, guys.
And there we have it. We have packets. That is Michaela Landivar
All right, guys.
on the ground.
Com, I want your report. Uplink and downlink, what do we got?
Okay, so I am seeing packets populate on the AOS screen and in the packet counts area. Looks like telemetry is coming in pretty well. We have not started uplink, so we do not have uplink locks at this point. But it looks like we are seeing most everything that we would expect as far as
That's an
downlink is
excellent
concerned.
call. We have reached
Okay.
a pivotal milestone. We're going to bring it back into the broadcast booth and congratulate the team working inside of Nova Control as our Noca-C lunar lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with Nova Control. What an achievement for the entire Intuitive Machines team. Let's honor this momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey. From Intuitive Machines' Nova Control in Houston, Texas, thank you for joining our portion of the IM-1 mission broadcast. We'll toss it back over to Megan in Florida for reaction to this successful launch of our IM mission. Megan.
Yeah, from here at NASA, we just want to say congrats to Josh and Intuitive Machines, another successful CLIPS launch and orbital insertion of a commercial lunar lander. Now, hopes are high that a U.S. commercial lunar lander will make it to the moon. And joining me now to talk a little bit more about that and this program is Chris Culbert, and he is the CLIPS program manager. Exciting to see this unfold right in front of us, huh?
Yeah, this is great. SpaceX gave them a wonderful ride, great launch, really clear sky. We could see it all the way up to the well, not to the moon, but on its way.
We saw the moon in the distance.
We could see the moon. It was a great launch. This is a great step. It's a lot of hard work to get here. This is 5 years of effort from a very small company, but they've made a lot of progress. They solved a lot of problems, and now they're on their way. So this is a good start, but it isn't the end yet. They got to finish the next step.
That's right. But at least we have 8 days, right?
We
have
do.
8 days.
Yeah. So they've got 6 days to get to the moon, and then we'll hit the hard step.
Yeah, so with the challenge of landing on the lunar surface, what's your message to the Intuitive Machines
So the big thing right now, they need to stay focused. Space is hard. Small mistakes can doom you. We know they're very talented. They're very well organized. We're really impressed with the depth and technical skills of this team, but you have to stay focused. You got to make sure you nail everything and stick the landing.
So again, a lot to look forward to, but we're optimistic.
Yes, we are. We're looking forward to it. I got a lot of faith in these guys.
Great. Chris, thank you so much. Glad to be here with you again for another CLIPS launch.
Thank you very much.
Okay, so that is going to wrap up NASA, Intuitive Machines, and SpaceX coverage of the launch of the Noca-C moon lander on a SpaceX Falcon 9 rocket from pad 39A here at Kennedy Space Center. Again, if all goes well, Noca-C is expected to land on the moon 8 days from now, so mark your calendars, on February 22nd. It would be the first U.S. landing on the moon since 1972. We'll, of course, bring you that coverage live right here on NASA TV. And until then, you can find out more about this mission and other NASA CLIPS launches by going to the link we're about to show on the screen here, nasa.gov/CLIPS. We're going to leave you now with a replay of today's launch for everyone here at NASA, Intuitive Machines, and SpaceX. I'm Megan Cruz, and have a great morning.
15 seconds.
And if you're just joining us, welcome here to the launch pad. You're looking at live telemetry from IM-1 on its way to the moon, and a beautiful replay of tonight's launch from Launch Complex 39A, which has launched its next mission. For the first time since 1972, 39A has sent a payload back to the moon, ushering in another new era for that pad. That's going to do it for us here from our TLP Canada studio. Our IM-1 live tracker is up and running, so we hope you'll follow along for all the updates as we track IM-1 over the next 6 days to get to the moon, and then a couple of days in orbit in advance of its landing. We'll be bringing you all the updates, but that's going to do it for us here tonight from our TLP Canada studio. We will see you next time, because space is better together, and go IM-1. We'll see you next time.